Hi guys, what we're going to do right now is that we're going to make a polymer. A polymer is a class of natural or synthetic substances that are composed of very large molecules. We call it polymer. Poly means many and mer means a unit. So actually a polymer has many monomers. You can think about a train that has all of these different boxcars that are bonded together. That's what a polymer is. In chemistry, we can have different kinds of polymers based on what their function is. We can have proteins. Proteins are polymers of amino acids. We can have nucleic acids like DNA and RNA. Those are polymers of nucleotides. We can even have some carbohydrates that are polymers like starch or cellulose. Those are very big molecules that have specific units that are bonded together. One of the ones that we're going to make right now, I'm going to synthesize or make one that is called nylon. You have probably heard of nylon. Nylon is used for fish nets or fishing line, is used for stockings, is used for making clothing, for a lot of different things. The ones that we're going to make today is called Nylon 66. A Nylon 66 is going to be a polymer that is made out of two compounds. One of them is the one that I have here in this beaker, and it's called 1,6 hexane diamine. Basically what it tells me right here, hex, hopefully you guys know, is the prefix for 6. So it has 6 carbons. And then amine. Amine means that it has it's a compound that has nitrogen in it. So we're going to have a unit of this that is going to intercalate with another compound that is called adipoyl chloride. Now this is a compound that has chlorine in it, and of course it has a lot of carbon as well. So what is going to happen once I make the nylon, I'm going to have a molecule of this compound bond with another molecule of this, then go back to this one, then go back to this one, go back to this one, and so forth. So let's see how we're going to make this. Like I said, right here I have about 30 mils of this 1,6-hexane diamine. And what I'm going to do right now, very carefully, I'm going to add the other compound, which is the adipoyl chloride. So I'm going to do it very carefully and see what happens. Oh, you can see that it's already smoking. So already a reaction is happening. Oh, let's actually watch that. That's pretty cool. So I'm going to start adding. Oh, look at that. Even the vapors is recognizing that I am adding another compound. So I'm going to add this very carefully. You can see that the layer of the second compound is forming. Now I will tell you why I'm adding this super slow. I have about the same amount of each. So I should get about close to 60 milliliters, more or less. Okay, so what you can see right here, I'm going to turn the hood on. What you can see right here is that we have these 2 compounds that I put in there. Now, one of the things that we will notice is that the nylon is actually going to form in the boundary between those 2 compounds. If I look, okay, over here, you can probably see that there's some kind of solid that is forming right there. That solid is going to be our nylon. And what I'm going to do is I'm going to start pulling it out. So you can see that in this situation we have 2 liquids that are going to form a solid. So I'm going to move this back a little bit. I'm going to use just this paper clip. I'm kind of like fish. Oh, look at that. Fish for my nylon. Again, it only forms in the boundaries between these 2 liquids. And I'm going to start pulling it. What I'm actually pulling is the nylon that is formed between these 2 compounds. Now, how much am I going to be able to get? Well, I'm going to be able to keep doing this until I run out of one of those liquids. Now I'm trying to not break it, but I don't know if I'm gonna be very lucky. Usually, oh, see, it already broke, but that's okay. I am going to add it to a test tube. Well, as you can see, I've been pulling some of that nylon and just wrapping it around a test tube. And if we have a lot of it and we are extremely successful with it, we should just be able to get like a long strand. I'm just kind of like doing here as a demo in terms of you can see that we start with these two liquids that they're forming a solid in the middle or in the boundary. You can see that I can still pull more. And what I'm gonna do now, I am going to see if I can make it safe. So I'm just gonna drop it here. This is just DI water. Once I actually clean it, I can touch it. And again, it could be because maybe our compounds were not as fresh as they should be, but this is what actually nylon looks like. And it's exactly the same that is used for clothing, fishing line, stockings, and you can see that I will dry it. And technically what we can do is that we can dry it and then we can check the properties to see if it's fragile or if it's strong. Of course, then this is actually going to be strung into ropes, and it's going to shape rope shape, and then it's going to look even stronger. But you can see that I still have some. I actually want you guys to see how it actually forms here, which is pretty cool. Okay, so now you can see that we made a polymer. Okay, so now here you can see that I have the nylon left, and I actually have it like in bulk instead of having it in a rope. But as you can see, it's dried out. So what I did is that I immersed it in water, and then I make sure that it was clean. And you can see that the nylon is pretty strong, but you know, we can not disintegrate it, but we can break it into smaller fibers. And again, what I said is that if we had it in rope, then those ropes can intertwine and make it very strong. And in this situation, you can even see a little bit where you can see that there's some little ropes that are forming. So this is the experiment of nylon, and I hope that you guys liked it.